So we're moving on to the number E. I know E is a letter, but we're doing the number E, roughly about 2.718. I actually prefer that to 2.72. And the natural log, which you'll see in the calculator, is ln. I'm well aware that n comes before L, but remember, English is not the only language that does this. So there's a little background knowledge on the number E. Some people remember E for exponential. Some people remember E for Euler. He's the guy that came up with it. But maybe more of a conversation should be left for class. And if you ever forget what the what E is, you can always hit second the division sign and then enter on your calculator, and there it is. You could also hit second ln, but then you just have to hit to the first power, because anything to the first power is itself, and you still get the same number. Which is actually why, if we look at the graphs of y equals e to the x, the correct answer on this one is option 2. And you can check with your calculator, you can actually learn from your calculator, but the reason for that is if you think back to when we did the base problems, and E is the base, and since we just said that E is about 2.718, that number is bigger than 1, that's showing exponential growth. And we can double check that that's the right answer if I go to the graph of this and I type into, here, let me just hide a few of these things because I'm going to use them in class. Second ln to the x power, and look at the graph. Yep, there it is. Looks like that same answer. Just kind of a heads up, you don't have to write this down, but if you remember, this is a parabola because it's a quadratic. It actually looks more like a hyperbola, but not the right answer. This would be exponential decay when the base is smaller than 1. And this kind of looks like a cubic to me. Certainly not the right answer. So as we progress through this, this next problem, they actually give you more information than you really need. So anyway, we have llamas, they're on an island, and we're representing this equation, 500 times e to the 0.035t. And if you look closely at that, and the first question is, how many llamas were introduced initially at t equals 0? To me, this is a redundant question. You should be able to know, let me cross that off, if I just said how many llamas were initially introduced, that's the starting amount. So let me just mention it this way. Is how much time happened if we started. Well, I hope you would say no time has happened, so t must equal 0. And I really think you could do this in your head. You don't actually need a calculator, because you could just go to that problem and plug in 0 and 4.035 times 0. And I think you can do this in your head because anything times 0 is 0. Let me go back and rewrite 500 times e to the 0 power. Because e to the 0 power, anything to the 0 power is equal to 1. So we're looking at 500 times 1, which means that there were 500 llamas to begin with. And then we can do some algebra to see when the population of llamas will get to 600. And so what we're going to do, based off of the previous lesson, is set this equation that they gave us equal to 600. And the reason why I say based off the previous lesson is you probably remember, hopefully you remember, that what we need to do is isolate the exponential part. And what I'm talking about there is dividing that 500 over. And what I like about this is that we can cancel out, that would reduce to 6/5. And let me do, because I haven't taught you the next thing, let's do just the change of base formula that you could log both sides. Now, if you're curious, there is an operation for log base e, so if you want to do the problem that way, that's fine. But I'm just going to use the change of base formula where I'm logging both sides, and the reason why that's going to work for us is I can move this piece in front so it turns into a multiplication problem, and we can solve multiplication through division. So my final answer for t, I hope you're understanding this, otherwise feel free to write down questions and bring them to class. It's log of 6/5 divided by not just that 0.035, but also that log of e. And as I go to type that in, back to my home screen, alpha x, make that fraction, log of 6/5 over 0.035 log of second division sign, and it spits out the right answer, 5.2 years. And remember, there's several ways that you could check your work. You could use the graphing calculator and look at the table and see that between 5 years and 6 years, you're going to cross over 600. You could type in 5.2 in for t and see that you'll get 600, or a number really, really close to that. But as I mentioned, there is an operation on your calculator that does log base e, and that's what we call the natural log. And as I mentioned before, it is ln, even though the English language writes nl, because again, we're not the only language doing math. So anytime you see ln, that's saying log base e. So in a few of these problems, I hope you can do this without a calculator, hence the directions, but you are allowed to use a calculator. So just think about it for a second, that's the same thing as log base e of e. And if you remember from a previous video, I asked a question, because we could do that boot method I mentioned, that e to some power should equal e, and that answer would be 1. In other words, natural log is a base of e, and when the bases and this number are the same, they cancel each other out, you're left with 1. Natural log and e cancel each other out. Just to show you, ln of e equals 1. I could do the same thing with the next one, but I hope we've done enough where you've recognized that no matter what the base is, if it's 1, it's going to be 0. Why? Because anything to the 0 power equals 1. With the next one, I'm going to explain it just a little bit different. And again, if I'm not explaining it well enough for you, just write down your questions and bring them to class. Because remember, our power rule, we can move that 5 in front. And natural log of e, as we mentioned before, is equal to 1. And something times 1 is going to be itself. So it's 5. And in the future, you might even see this in other classes. You might even have a teacher that sees that and automatically crosses that out and jumps to that final answer. I could do the same thing with the next one. It might help you understand why the correct answer is 1/2. If you think back to what I was saying, is that square root is the same thing as to the 1/2 power. Now technically I'm moving that 1/2 in front, and it's 1/2 times 1, because natural log of e is 1. But you might actually see a teacher in the future, they'll just look at that and they'll cross out that natural log of e and write down 1/2. So I'm trying to prepare you for whatever you might see in the future. And I could do the same thing with the next one. All the laws of logs, the 3 basic log laws that we had before, still follow. And we're going to practice them. So recall for a second that when we divided, we could split them up using subtraction. So division, subtraction. So it becomes natural log of x cubed minus natural log of e squared. And from this point, we can practice our power rule where we move that 3 in front. And remember, natural log of e is just 1 with that 2 right there. Otherwise, feel free to do some more work. Move that 2 in front, and then it's 2 times 1. But no matter how you do the problem, the answer is option 2. And just a few more. Now, sometimes in your assignments, you'll have to leave your answer in exact terms. That means that E needs to be part of your answer. And sometimes they'll want you to round the answer. But just like before, when I wanted you to isolate your exponential part, with this one, I suggest to isolate the log part. In this case, it's natural log. So to do this problem, I'm going to try to do this step by step, but I hope at some point you'll just get on board with this, that you add 5 over. 3 plus 5 is 8. And then the next step is to divide by 2. So we're looking at natural log of x plus 3 is equal to 4. At this point, I usually just change this to exponential form. Let me just write this over here. That, remember, the implied base is e. Now, technically what I'm doing is I'm taking e to both sides to undo that. So in exponential form, it's e to the 4th power is equal to x plus 3. So my final answer, now that the log is gone and we got rid of it, is e to the 4th minus 3 to move that 3 to the other side. And I think this is our last problem because we're working with inverses now. And if you remember, what we do for the inverse is we switch x and y, and then we solve for y. So in this problem, that's exactly what I'm going to do. I'll switch back to a different color. X equals natural log of y minus 8 plus 2. And when we go to solve it, it's going to be the inverse operation. Subtract that 2 over. And then from here, whether you just change it to exponential form or you think about to undo the natural log, you take e to both sides. So we're looking at e to the x minus 2 power is equal to y minus 8. And so my final answer, whether you prefer inverse notation or you just write as y equals, I'm good either way, is e to the x minus 2 and then plus 8. And I believe that's it. You should be ready for the homework now.